Hello friends, today I will discuss about molecule Broflanilide. It is used as insecticide. The molecule was discovered by Mitsui Chemicals from Japan. Here is the chemical structure for the molecule. In next few slides, I will be discussing about three different synthetic routes for the molecule. First, I am showing the discovery route as described by Mitsui Chemicals in this mentioned patent. The reaction starts with this ortho-trifluoromethyl First, they coupled it with a polyfluoroalkyl iodide in presence of tetrabutyl ammonium bromide to install this polyfluoroalkyl group selectively at the para position of the amine group. Next, they have done bromination at the ortho position of this amine group by using N-bromosuccinimide reagent. Next, they have used this nitro and chloro substituted carboxylic acid and thionyl chloride they have used to convert this carboxylic acid in situ into corresponding carbonyl chloride that reacted with the amine functional group of this molecule to generate the intermediate 7. Next step was SNAR reaction to displace this chlorine by fluoride. For this purpose, they have used this the potassium fluoride as the fluoride source, uh, but yield was not that much good. You can see yield was only 20% at this step. Next, they have reduced this nitro group to amine group by using tin chloride. In the next step, they have performed one methylation on this primary amine group using formalin in presence of concentrated sulfuric acid, followed by coupling with this benzoyl chloride to install this benzoyl group on the nitrogen center to get the final molecule. However, in this process, overall yield of this molecule was less than 10%. So they modified process. So that process I will be discussing on next slide. Here is the modified process. In last described slide, I mentioned they installed that polyfluoro moiety at the earlier stage, but here they followed different strategy. They started with this carboxylic acid and they converted into the methyl ester using methanol in sulfuric acid, followed by SNAR reaction using fluoride reagent. Here they have used cesium fluoride instead of potassium fluoride and they got better yield. And next step was the reduction of the nitro group to corresponding amine using hydrogen. Next, they performed methylation of this primary amine group using formaldehyde in presence of sulfuric acid. Followed by they have performed benzoylation using benzoyl chloride in presence of pyridine as a base. Now they have done this hydrolysis of this ester group to convert into corresponding carboxylic acid, and at the last step they have performed this coupling reaction with the fluoro substituted amine. So here they have used thionyl chloride to convert carboxylic acid to carbonyl chloride, and that reacted with this polyfluoroalkyl substituted aniline to get this final molecule. In this process, yield improved little bit, like it was around 20.5%. Now I will discuss about the third route. That route was published in OPRD journal, and the authors mentioned that overall yield of the final product improved up to 60%. So in earlier methods I have mentioned that authors have used chloro-nitro substituted benzoic acid derivative, and later they have performed that SNR reaction for fluorination by replacing chlorine. Here the authors directly started from this fluoro substituted carboxylic acid. and they have coupled with this polyfluoroalkyl substituted aniline derivative to get this intermediate. And next they have performed this nitro to amine reduction step using hydrogen in presence of palladium charcoal. Next they have performed methylation on the primary amine group using paraformaldehyde, and at this step also they have improved the yield using platinum as catalyst, which helped to get better yield by suppressing side reaction formation like dimethylation. And next step was benzoylation by using benzoyl chloride as the reagent, and the final step was the bromination. For this bromination step they have used sodium bromide in presence of sodium hypochlorite. Thanks.